Hello students, today we are going to study about nucleophilic substitution. Bimolecular reaction, which is also known as SN2 reaction. Earlier you had studied about the SN1 reaction, which is nucleophilic substitution unimolecular reaction. In this session we will discuss about what is SN2 reaction, its reaction and mechanism, kinetics of SN2 reaction, energy profile diagram and the factor that are affecting the rate of SN2 reaction. Come to introduction part here. Though SN2 reaction is a substitution reaction, so in nucleophilic substitution reactions, the attacking species is a nucleophile. Primary alkyl halide usually favors SN2 mechanism, which involves one step. Consider the hydrolysis of methyl chloride with potassium hydroxide. In this reaction, methyl chloride react with potassium hydroxide undergo nucleophilic substitution reaction, where hydroxyl ion, O-, is the nucleophile which replace the chloride ion, Cl-, to form the methyl alcohol and potassium chloride. Then we'll see the mechanism of SN2 reaction. How the mechanism of SN2 reaction proceed through one step. SN2 reaction involves the backside attack of nucleophile on the substrate. In this reaction, O- is the nucleophile, which is attacking the methyl iodide from the backside. Here I- is the leaving group, to form a transition state, where the breaking of carbon-halogen bond and formation of carbon-nucleophile bond occurs simultaneously. This transition state is most unstable state because carbon is having 5 bond. In transition state, the 3 hydrogen atom attached to the central carbon atom with a bond angle of 120 degree. It is important to note that the product so is formed in SN2 reaction is inversion of the tetrahedral geometry of the atom in the center. The reason is that nucleophile is attacking from the backside of the leaving group. This is the explanation of the mechanism of SN2 reaction, which I have explained in the previous slide. Next is the kinetics of SN2 reaction, whether it is first-order reaction or second-order reaction. The rate of SN2 reaction is second-order because we know that our SN2 reaction proceeds through one step, which is the rate-determining step, and it depends on the concentration of nucleophile, Nu, as well as the concentration of substrate Rx. Therefore the rate of SN2 reaction is directly proportional to the concentration of both the alkyl halide and nucleophile. Now we'll discuss the energy profile diagram of SN2 reaction. This graph is drawn between progress of reaction at x-axis versus potential energy at y-axis. In this graph the reactant molecule, O and CH3Cl, react among themselves to give the product, CH3OH, via transition state. It shows that no intermediate is formed but reaction involves a single transition state. And this transition state represent highest activation energy, so it is a unstable state. The reason is that activation energy is inversely proportional to the rate of reaction, that means higher is the activation energy, slower is the rate of reaction. Next one is the factor affecting the rate of SN2 reaction. There are 4 factors which affect the rate of SN2 reaction. First is nature of substrate, that is alkyl group. Second is nature of leaving group, that is halide ion. Third is nature of nucleophile, and fourth one is nature of solvent. Here we'll discuss all the factor one by one, how they are affecting the rate of SN2 reaction. Nature of alkyl group. In this diagram you can able to see the reactivity order of different alkyl halide, containing same halogen atom increases from tertiary alkyl halide to methyl alkyl halide, which is most reactive towards SN2 reaction. Methyl halide is more reactive than primary alkyl halide, which is more reactive than secondary alkyl halide, which is reactive than tertiary alkyl halide. Then why primary alkyl halide usually favors SN2 reaction but tertiary substrates do not participate in SN2 reactions? This is because of steric hindrance. Though the nucleophile attack the alkyl halide from backside, so the less sterically hindered alkyl halide or substrate react more readily under SN2 reaction. Second factor is nature of leaving group. Better the leaving group, more stable is the transition state. The stability of the leaving group is directly proportional to the basicity of the nucleophile. Therefore, lower the basicity, that means weak base, better is the leaving group. In SN2 reaction the reactivity order of alkyl halide is alkyl iodide is more reactive than alkyl bromide, which is more reactive than alkyl chloride which is reactive than alkyl fluoride towards SN2 reaction. Next factor is nature of nucleophile. The rate of reaction mainly depend on the nucleophilicity of the nucleophile. Nucleophilicity means the ability to donate pair of electrons. A species with negative charge is a strong nucleophile than neutral species. In SN2 reaction, the order of nucleophilicity of the nucleophile is Cn- is greater than I-, then C2H5O-, Hen O-, C6H5O-, Cl-, and CH3COO-. Last factor is nature of solvent. The rate of reaction depends on the polarity of the solvent to stabilize the transition state. There are two types of solvent: polar protic solvent and polar aprotic solvent. Polar aprotic solvent favors SN2 reaction and this is a type of polar solvent which do not have acidic hydrogen. This diagram showing the increasing order of effect of solvents towards the rate of SN2 reactions. Thank you, and for any further clarification and doubt please let me know.